First, you started from the role of water, then we move on to the pH value, the strength of the acid and alkali. Next will be the chemical properties of acid and alkali. And these chemical properties is actually important. These chemical properties and the preparation of salt. Both of these actually they are highly related. So if you don't know these chemical properties of acid, then you cannot prepare the salt. Okay. And next, again, calculation. So in this chapter, you have a few parts that relate with calculation. pH value, calculation number 1. Concentration, calculation number 2. Standard solution, calculation number 3. And neutralization, calculation number 4. Okay. And of course, in this case, we can also determine the mass of the salt produced, where we can talk about that part in either the preparation of salt or the effect of heat on salt. This is the 5th calculation. So these are all the things that you are going to study. And what is the important part that I'm going to tell you today will be the part on how you should answer your exam questions. Content-wise, I'm very sure all of you have no problem. Maybe you will miss out at the part on how to write your answer correctly. Okay, so next we are going to talk about some definitions that you have to know. Because in this part, if we are talking about questions on the explanation wise, we are going to explain based on the definitions that we have learned. So the first one, what is the important keywords here will be this. You have to use the word substance. If you are asked to define acid, many students, they just say that acid dissolves in water to produce hydrogen ion. But you have forgotten this word, the substance. Same goes to sometimes the question asks you about the alkali. But our students, you forget about the alkali to relate to the hydroxide ion. You still write about the hydrogen ions. Then this is the part that caused you to be wrong. Now the next definition that you should know will be about the strength of the acid and alkali. We are talking about strong. When we are talking about the word strong, meaning we are going to have high concentration of hydrogen ions. If you don't want to use the word dissociate, you can use the word ionize, is okay. But make sure you write either it ionized completely or it ionized partially. If it is a strong acid, it will ionize completely. And make sure you talk about the water. And the most important part that most of you will forget will be the high concentration of hydrogen ion. Same definition we are going to use to define the strong alkali. But then we are going to change the hydrogen ion to become the hydroxide ion. And if we are talking about the weak acid or the weak alkali, then this word completely will be changed to partially, and the high concentration, it will become the low concentration. And of course, the hydrogen ion and the hydroxide ion will be tallied to the acid and the alkali. Okay, are you okay until here? Am I too fast for you, or am I too slow? Any response from you? Just okay, Okay, thank you. Now we move on to the last definition that you should know. These are the part on the basis. The basis, what is the meaning? So far, the question will always ask you about the alkali. The question will always ask you about the alkali. They don't ask you about the base. That's why many of us has forgotten about what is the base actually. Okay, so base is actually, again, you have to use the word substance. This is the part that many students will leave out. What can it do? It can neutralize acid. But what is the meaning of alkali? Alkali is actually a base. But then this alkali is a base that can dissolve in water. That's why when we want to define the alkali, we are using this definition instead of it can neutralize an acid. Okay. Of course, the alkali can neutralize an acid, but then it is actually under the chemical properties of the acid and alkali part. Okay, so these are a few definitions that you have to know. And next, we move on to the questions that I have given to you. And from these questions, I am actually covering most of the parts of your chapter. Okay, now the first thing that you have to see will be, this is the manipulated variable where when you see the concentration change, the pH value will also be changed. And from here, we can actually make a hypothesis if you are talking about the paper 3. Okay, so if we are talking about paper 2, you can actually state the relationship. Of course, in paper 3 also will have relationship, but in paper 2, when we are talking about relationship, that means we are relating the concentration to the pH value. Now, what is the relation that we can talk about? You will see that the concentration, you see the number is getting lower, but the pH value is getting higher. Therefore, we can say that as I am using the blue, my answer, as the concentration becomes lower or as the concentration decreases, good, the pH value increases. This is the way you write the relationship. Remember, the MV should be always in front. Okay, next we go to the next question. And the stem of the questions given to you stating that this is the pH value of the hydrochloric acid. Therefore, we are going to tell that as concentration of acid decreases, the pH value increases. And please take note, when you always do your question related to the pH value, please draw this line where you are putting 1, 7, and 14 to represent the pH value. Now, if you have this line, those value later, if you are locating it in the range which is near to 7, then this partner is for either the weak acid or the weak alkali. How do you determine acid? Of course, if the value is below 7, so this is the acid. So if it lies here, then it will be a weak acid. If it lies here, then it will be an alkali because the pH value is higher than 7. This is what you have learned in your lower form science. So I don't talk more about that, but I am moving on to the next part where how you relate the question to the definition that I have given to you. Hydrochloric acid is a strong acid, the keywords, and what is meant? What is meant means you are writing the definition. So again, we are going to say that the strong acid, you can say that it is an acid, or if you don't want to use the word acid, you can substitute it with the word substance. That dissociate, if you don't want to use dissociate, you can use the word ionize. Completely in water, don't forget high concentration of hydrogen ions. Okay, so this is the part where how you relate to the definition to the question. And the next part, okay, the next question asking you to predict the concentration of the hydrochloric acid where it has a pH value of 4. And here we are going to relate to a calculation formula where we are using this formula. The pH will be equals to the negative log of the concentration of hydrogen ion. When you see this square bracket with the hydrogen ion inside there, it means the concentration of hydrogen ion. Now, how do we know about the concentration of hydrogen ion? Now, see here, if I am giving you an equation to show the dissociation of the hydrochloric acid, if I am having 0.01 mole per decimeter cube of the hydrochloric acid, this is the unit to represent concentration. Indirectly, I am telling you, I am also getting 0.01 mole of the 0.01 mole of the hydrogen ion, the same concentration. Again, if I have 0.01 mole per decimeter cube of hydrochloric acid, Indirectly, I am telling you I am having 0.01 mole per decimeter cube of hydrochloric acid. What is the reason? Because the ratio of the HCl is to the hydrogen ion will be the 1 is to the 1. I hope you can understand until here. Therefore, according to our table just now, here, this table, can you see? Given to you, this part is the concentration of the acid. So indirectly, this is also the concentration of the hydrogen ion. Now the question gave us the pH value to be 4. So we are now going to get the concentration on the hydrogen ion. How do we get? We are going to put it anti-log, negative pH. From log, you want to change, it is anti-log. Okay? The negative, put it to the other side, it becomes negative pH. So the pH value given is 4. So you substitute in, you press your calculator, you are getting 0.0001. Is my answer correct? If you think it is correct, say a yes. If you think it is not correct, say a no. I want to listen to your response.
Yes.
Yes.
Oh, yes, everyone agree. Tom and Jerry, you got trapped. I previously told you I want the concentration of the hydrochloric acid. So concentration, what must be there?
Mole per
unit.
dm3.
Yes, good. If you don't write this, then you don't get the marks. This is something that you should remember for your exam. And for this case, yes.
Sorry, teacher, what do you call it? So the concentration of the hydrogen ion in the acid is already the concentration of the acid itself.
Now you see, I am coming back to this equation.
Okay.
Okay. From this equation, the ratio of hydrochloric acid is to the hydrogen ion. It is
It's
1
1
to
into
1.
1.
Okay. Now, if I have 0.01, I am also having 0.01 of the hydrogen ion. Agree? And of course, I am putting in the unit. So in this case, the unit is mole per decimeter cube. So this one also mole per dm cube. This is how you generate from the table for the value, and you will get this. Okay, understand now?
Understood.
Okay, thank you. And this part here, remember to put in the unit. Many students, when they get this 0.001, they are very happy already. Wow, I get the value already. Faster you write down in your answer scripts. But then you forget, oh, concentration must have the unit of mole per decimeter cube. Can I move on? Are you okay with this?
Yes, teacher.
Okay, thank you. Now we move on. Next part of the question, you are asked to calculate the volume of the 0.01 mole per decimeter cube of hydrochloric acid required. What is being prepared? You are going to prepare 1000 cubic centimeter of the hydrochloric acid, and the pH value of this hydrochloric acid to be 3. So now, from this solution, I want to get this. And what is this? This is actually on the part of the preparation of standard solution. For those who have not remember or you have forgotten about the meaning of solution, the standard solution, it meant that it is a solution with a known concentration. And this concentration should be known accurately. So in all, the standard solution is a solution with a known concentration. Now we move on. And what is the meaning of the pH value of 3? Referring to your table just now, you'll find that the concentration is to be 0.001 mole per decimeter cube. Now look at the initial concentration, 0.01. This is initial. From this one, you want to get this 0.001. Can you see this? And from 0.01 to this value, the concentration actually decreases. And when you see the concentration decreases, they are actually telling you about the concept of dilution. And the formula for you to calculate, it is M1V1 equals to M2V2. There are two new formula for you to use in this chapter, so you don't mix up. If you mix up, even though you get the same answer, might not be necessarily correct for you. Okay, now here we are going to substitute this value where the M1 is the initial solution given to us, 0.01. The V1 is what we want to look for. This is the concentration of the final solution, and we are actually looking for the we are actually preparing 1000 cubic centimeter of the solution. And now I want to show you how do I come to the unit of cubic centimeter. These three should be a superscript. Okay, now you see here, you have a mole per decimeter cube on the left. You have also one on the right. So you cancel it off, cancel it off. Can you see? Only this left. That's why your unit is the cubic centimeter. I should let you know about this method is because sometimes when during exam, you find it very difficult to get your unit correctly written. And this is the method for you to determine. No panic. All chemistry questions are simple, right? I hope you agree with me. And maybe in your heart, you start scolding me. Hey, what is this? Never before chemistry is simple. Don't think, is it? Don't take things to be difficult. Okay, nothing is difficult. Now, part D. Can I move on? Are you okay with the calculation just now?
Yes.
Yes.
Yes, good.
Yes.
Now we continue. Part D. The pH value of the ethanoic acid given to you is 4, and for the hydrochloric acid is 1. But what is different, what is the same is that the concentration are the same. Did you see? 0.1 mole per decimeter cube of ethanoic acid, 0.1 mole per decimeter cube of the hydrochloric acid. So in this case, what is the question is trying to test you is they want to test you on the strength of acid. When we are talking about strength of acid, we talk about the strong and the weak. Okay? Therefore, you will have your answer as this. First, you talk about what do you know about the ethanoic acid. First thing, it is a weak acid. Then you relate to the definition. Can you see just now I told you definition is important in this chapter. So you have to relate the definition to what you write in your explanation. Dissociates partially in water to produce low concentration of hydrogen ion. This is the definition. Then you talk about the hydrochloric acid. Again, you relate to the definition. Now this is the part, the one that I put star, is the part where many students will forget. After you happily write about the strong acid and the weak acid, then you compare. Don't forget to compare. Compare what? Compare the concentration of hydrogen ion in both acids. Then you write a sentence to relate the concentration of hydrogen ion to the pH value. So this is the standard answer for the questions that ask you to compare two acids. And if they ask you to compare the hydrochloric acid and the sulfuric acid, then what are you going to compare? You are not going to compare based on the strength, but you are going to compare based on the basicity. Now, what is the meaning of basicity? Maybe you forget about this, but I'm very sure you know what is monoprotic acid and what is good diprotic acid. So you relate, or the HCl is the monoprotic acid, where 1 mole of the HCl will produce 1 mole of the hydrogen ion, blah, blah, blah. And also you talk about the diprotic acid, then again, the third sentence and the fourth sentence will be the same. So that means when you first get your question, this part, you have to know about the acid given to you, and you have to determine, are you going to compare based on the strength or you compare based on the basicity. Okay, now talking about the strength of acid, I would like you to take note that this H3PO4, do you know what is the name of this?
Um, phosphoric acid.
Good, phosphoric acid. And is this a strong acid or a weak acid?
A strong acid.
I'm sorry, you are wrong.
It's
This is a weak acid. Okay, now this is a weak acid, but at the same time, it is a triprotic
triprotic.
acid. Okay, so it is called as a weak triprotic acid. Okay, now why weak triprotic acid? Weak is because this H3PO4 will dissociate partially in water, and it will produce low concentration of hydrogen ion. And if this molecule dissociates completely, it will produce 3 mole of hydrogen ion per molecule. That's why it is called as the triprotic acid. Okay, many students will mislook for this part. So the phosphoric acid is the weak acid. Okay, now we continue to our next part of the question and part E. When you are putting SS, take note about this word, SS. SS means number one, the reaction, RXN, my short form for reaction, complete. And which is the limiting reactant? This one. The hydrochloric acid is the limiting reactant. Do you know what is limiting reactant? If you don't know, just tell me something. If you don't know, you say you don't know.
The limiting factor.
Okay, correct. The limiting reactant is the limiting factor, correct? Okay, so that means in this reaction, which will be finished off? Which will used off? The lead-2 nitrate will use off or the hydrochloric acid will use off?
The hydrochloric acid.
Good. The hydrochloric acid will use off. Okay. And this hydrochloric acid, when it used off, and we will say that if the question asks you to state which is the limiting reactant or the limiting factor, the answer will be the hydrochloric acid. And now, if you are asked to explain, please don't forget to use the word all. All the hydrochloric acid will react completely with the PbNO3. Okay, I want to emphasize on the word on the all, and also completely. Both words have to be there if you are asked to explain. Okay, now on the screen I showed you the chemical equation for this reaction, and this is the answer for the question part 1. Now from this equation, we know that this is a chemical equation. I hope you can differentiate the chemical equation and the ionic equation. Is there anyone who cannot differentiate? If you cannot differentiate, please tell me you can't. Can you differentiate between the chemical equation and ionic equation? You can, okay? Now, this is precipitation. So, for your revision, if you want to write the ionic equation, you just take the precipitate, separate it into its ions, and you get the product. So, 1 Pb on the left, 1 on the right, 2Cl, 2Cl. Then your charge will automatically be balanced up. Okay, so this is your answer, and this is some extra information for you. Now, next part, when we want to calculate the mass of the lead-2 chloride precipitated, and we are going to calculate first the number of mole, and this is a solution we are using mv over 1000. Remember, whenever you see it is a solution, you have only one formula for the number of mole, which is mv over 1000. If it is a solid, can I have any response? What will you What is the formula that you will use for the calculation? If it is a solid, any response? Anyone? Oh, you don't know?
It
Oh,
was gram per cm cube.
okay. Now you are taking the mass. Maybe it will be in gram. If it is in kg, please change it to gram, and it will be over the molar mass. Remember, the mass have to be in gram. Okay? Why? Because the molar mass will be in gram per mole. So when you have gram and gram per mole, up and down, you can cancel off to give you the mole. And if the questions gave you about the volume, then you are going to take the, it is a gas. Normally, if they give you in volume, that means it is a gas. And you are using the volume over the molar volume. And please make sure that this volume is in the unit, which is the same as the molar volume, either both cubic centimeter or both decimeter cube. Okay, now we continue. This is a solution given to us. Therefore, we are using MV over 1000. Next, after that, we are taking the ratio. Now, of course, in your textbook, you will see that it will be putting 2 mole of this HCl will produce 1 mole of Cl2. In exam, you can actually represent it in ratio form, but you must have 2 lines. These 2 lines must be there with the presence of what you want to put it to ratio. And finally, we are going to move on to the requirement of the question, which is the mass of the lead 2 chloride. Okay, so remember, this type of calculation will be always, I call it as the 3 steps calculation. What are the 3 steps? It will be number 1, the number of mole, number 2, the ratio, and number 3, the requirement of the question. Now, this requirement can be the mass, can be the volume, it can also be the number of particles. You read the question carefully and identify the keywords from there. I hope you are okay until here. Okay, and the last part, we are going to predict the lead 2 chloride precipitate is filtered. That means this one filter. Filter means this one will be on top, and down here, this is the solution, and we are going to do some revision. This is called as the residue, and this will be called as the filtrate. Okay, now the question says predict the observation. Can you see I purposely put a circle at the observation? Now this observation is something that you see. What can you see? You can see about the gas bubbles, and you can also see about the color change. What am I writing? Okay, color change. So this is the meaning of observation. In observation, you don't tell me the name of the product form. It is wrong. Okay, and now you are asked to predict the observation that will take place when the calcium carbonate powder is added to the filtrate. So the residue is actually the PbCl2. The filtrate is actually the HNO3. Now the question is asking you, when the calcium carbonate is put into the filtrate, then what do you see? Actually, on the screen, I've already shown you, this is the chemical equation represented. That will represent what is told in the question up there, where which part will give you the observation. It is this. We don't talk about the calcium nitrate. Why? Is calcium nitrate soluble or insoluble? Someone please. Is calcium nitrate
soluble?
Yes. When it is ended with a nitrate ion, it will be soluble. So when a soluble salt with water, this is a solution. And what is the color of the solution? Do you know? Smart guess, colorless solution. Normally, when you have nitrate salt, If they don't have the copper 2 ion, the iron 2 ion, the iron 3 ion, okay, if they don't have this, the powder or the solid state of the nitrate salt will be in white color. When you dissolve it in water, then it will become colorless solution. So now in this case, we are not going to say that the colorless solution is formed, because initially the HNO3 is also colorless. You don't see any color change. But what you will see is this part. When you put in, if there is carbon dioxide gas to be produced, you will straight away see the colorless gas bubbles. Therefore, your observation will be the colorless gas bubbles are released. Okay, I hope you are okay for this question number 1. Any problem before we move on? No, okay.
Wait,
So
teacher, can we
yes.
see the part where we have to compare the concentration?
Which part? Which question? Or this observation?
No. The question where we have to compare the concentration of hydrogen ion in the two different acids.
Go on. I show you the slide. Is it this part?
Yeah, that part.
Okay. What is your problem?
We want to talk about basicity, we have to change the first two sentences, right?
Yes.
But the last two, we have to keep it.
Yes. And for
Okay.
the last two, normally if we are talking about the H2SO4, if we are talking about the H2SO4 and the HCl, we will know that this H2SO4, when it dissociates in water, it will produce actually 2 mole of the
1 mole of H2SO4 will produce 2 moles of the
yes.
hydrogen.
And you will find that the ratio of the hydrogen ion of the H2SO4 and the HCl will be double. So normally in this sentence, the one that I put in green, we will say that the concentration of hydrogen ion in the H2SO4 is double than that in the HCl. Later in the next question, I will have one part on this. Okay?
Okay, thank you, teacher.
Okay, okay, thank you. So now we are, any more questions before we move on? No more? Then we are going to move on to question 2. Now everybody see this picture. Some of you will feel happy. Some of you will feel sad because you know that you have to do calculation. And not all neutralization question will make you to do calculation. Actually, it can be related to daily life, where this can be used to produce fertilizer. And do you know how to determine a better fertilizer? If I am giving you A and B, you want to choose which is a better fertilizer. Now I give you hints. You are going to calculate the percentage of nitrogen by mass. The keyword by mass must be there. Okay, so you calculate. The one with the highest percentage of nitrogen will be the better fertilizer. Why? Because the plants need nitrogen for the synthesis of protein. Now we continue to this question. Look at the important part. At the burette, always put the acid. You don't put the sodium hydroxide. Of course, it is not wrong, but then it will spoil your burette. So always at the burette, you are putting the hydrochloric acid, and make sure you know the concentration. And at the conical flask, you are putting in not only the alkali, but also the indicator. Please take note about the spelling of phenolphthalein. 3 times of H it occurs, okay, which is the pH, and TH. Phenolphthalein, PHE, 1 time of H, NOL, again PH, then THALEIN. Now this spelling is very important. If you write it wrongly, then you will have no marks. And next, here, if the phenolphthalein in alkali, it will be in pink. So later, when the endpoint reaches, it will turn to colorless. Now, if the question asks you, how do you know that the endpoint reaches? Then your answer will be, the color of the solution will turn from pink to colorless. Now, not necessarily the question asks you, state the color change at endpoint. That one is how many centuries question already. That one is Jurassic Park question. We don't want that. If I want you to think more, I will ask you, how do you know that the endpoint has reached? So you tell the color of the solution will change from pink to colorless. Okay? Now it is using the same answer, but then they just change the wordings of the question. Now we continue to the next part. Any problem before I move on? No. Now here the first question again, the definition of strong acid. I don't talk about it anymore. And now I want to talk about part B. Suggest an apparatus that can be used to measure the 25 cubic centimeter of sodium hydroxide keywords accurately. Please change this 3 to be a superscript. Now, there are a few apparatus used for your measuring in your lab. The first apparatus, we will always see the measuring cylinder. When you are a small little boy and small little girl, you use measuring cylinder many times. Okay? Then, when you move higher level, you listen about the burette and you also listen about the pipette. Of course, in Form 1, you were told about all this already. Now, they are all used for measuring, but then they have different purpose of measuring. If you just want an approximation of volume, you use the measuring cylinder. But if you want something accurate, you will use either the burette or the pipette. Now, in this case, they tell you a fixed volume. Fixed volume means you are going to use a pipette. If you forgot how does the pipette looks like, you were at home for so long already, this is the pipette. When you measure, you are going to put a pipette holder up here, a pipette filler up here. You press it to suck up and it has to reach the calibration mark. Your hand should touch this point, not here, cannot. Because your hand has got heat, it will make this part of the glass to change its size, even though it is very less amount of heat, but then it will affect. So your hand will be holding up here. Okay, so now this is a pipette which is used to measure a fixed volume accurately. So what about the burette? The burette is to measure accurately, but not a fixed volume. It can be any volume. Okay, now we move on. Next part of the question, again, the color change at the end point. The word change is important. That means you have to put the initial color. This is the initial color to the final color. Any questions about color change have to talk about initial to final, because you are standing there to see initially until the final. Okay, next, we are going to write equation for the above reaction. So where do we get the chemicals that is involved in the reaction? It will be the NaOH and the HCl. All this is from the diagram and also from the stem of the question. Okay, and next, this is neutralization. The method that I showed you with the burette and the conical flask just now is called as the titration method. Titration is a method and neutralization is a process. I hope you are clear with this. And when we are writing the ionic equation for any of the neutralization, we don't care what is used as the acid, what is used as the alkali. The ionic equation will be always the hydrogen ion reacts with the hydroxide ion to form the water molecule, because the water molecule is the main character in neutralization. And that's why when you define heat of neutralization in your thermochemistry, you will say that the heat change when 1 mole of water is formed from the reaction between the acid and the alkali, okay, under standard conditions. That is why the water molecule is important. Now we continue to the next part of the question, giving you 20 cubic centimeter of hydrochloric acid is needed to neutralize 25 cubic centimeter of the sodium hydroxide solution. Keywords are neutralize. When the word neutralize is there, they are actually telling you what is the formula that you can use for your calculation. And I want you to take note about the word molarity. Molarity means concentration, but then this concentration must be mentioned in mole per decimeter cube. And you don't forget, you will have another formula to calculate for the molarity, which is gram per decimeter cube. But when we are talking about molarity, this is the one. This one, no. Okay, now we move on. From the word neutralize, we know that we are using the formula of the MAVA over MBVB. And what is all this? MA is the concentration. M is concentration. If you see the A means acid, the B means the base. And now this A and this B is actually this A and B. This A is the number in front of the acid to balance up the equation. This B is the number in front of the alkali to balance up the equation. And when you put in the values, this 0.1 is measured in the unit of mole per decimeter cube. This 20 measured in cubic centimeter, 25 cubic centimeter. When you have cubic centimeter up and cubic centimeter down, cancel, and at last your calculation will have the unit of mole per decimeter cube. Again, this is the superscript, I'm sorry. Okay? Can? And please remember, you have one fraction on the left, one fraction on the right. You are doing cross multiplication. Any problem until here? Should I move on?
So wait, teacher, the ratio is 1:1 because of the mole ratio, right?
Yes, the 1:1 is the not the mole ratio. This is the coefficient.
The coefficient ratio, yeah.
If I change this to become H2SO4, then this one will be 1:2. Do you know why 1:2? That is when you balance up the equation. Can you, dear? Can you?
Yes.
Okay, now we move on. Next part. So now the next question. What you want is here. See, the experiment is repeated using the same concentration, but this time we are using the sulfuric acid. Just now when we were using HCl, we need 20 cubic centimeter. And we know that HCl is a monoprotic acid. Okay? Now when you are using the H2SO4, what is the volume of the acid needed? Any response from you?
Less.
In this question, you cannot put less. Less is how much? Less is how much?
Half.
12.
Half of it.
Is it? Just now I told you that the concentration of the hydrogen ion produced by the sulfuric acid is double than that of the hydrochloric acid, right? Therefore, now what we need is only half of it, which is 10 cubic centimeter. How do you get this? You are going to calculate mv over 1000. Your m is constant, 0.1. Your v will be differ. Okay? Now someone press for me, mv over 1000 for the hydrochloric acid? Do you have your calculator with you? You should be getting 0.002 mole. Agree? Or you are not pressing? Are you pressing?
Agree.
Do you get 0.002? Yes or no, dear?
Yes.
Good. Now we continue. Meaning to
Yes.
say, thank you. When we want to predict the volume of the sulfuric acid, it should be also equals to 0.002. And when you do your calculation here at last, you will get your V as 10 cubic centimeter. Okay. Now we want to explain why 10 only. This is the story. The hydrochloric acid is a monoprotic acid, while the sulfuric acid is a diprotic acid. When you compare, I want you to take note about that. In your exam, when you write your answer, if they are giving you two chemical substances, then when you write your answer, you should be writing also about the two chemical substances, which is in this case the HCl and the H2SO4. You don't write only for one. If you write only for one, and if the mark scheme wants two, then you don't get your marks. Our role is to do our best. We don't care what the mark scheme want. We are writing the perfect answer every time we do our practice. Okay? Only perfect practice give perfect results. Not practice make perfect. It's only perfect practice makes things to be perfect. Okay? Now we continue. So the next sentence, can you see? The number of mole of hydrogen ion is twice than that in the hydrochloric acid, or is double than that in the hydrochloric acid. And this is the answer that your friends won previously. Now we move on to the next part of the question. Question 3. Now from question 3 onwards, I put it to be essay question to you. But then essay question is not difficult. Essay question is simple question that you can answer. I'm very sure all of you can. You look at the question itself, they are giving you some hints actually. Now propanol and water. In propanol, there is no change in the color of the litmus paper, but when it is in water, there is some change. Now what can you tell me about the ammonia in water? Acid or alkali? Anyone? Are you still there? Oh, good, thank you.
Alkali.
Very good. Wow, you are still there. You do in a relaxing manner. You can bring your coffee with you. You can bring what else? Your teddy bear with you. But you don't leave me. Here. The ammonia is an alkali, correct? Okay. Now, alkali means in our mind, we relate to the hydroxide ion. Always in exam, when you get alkali already, you write down this hydroxide ion so that you don't forget. Now, actually, this question tells you about the role of water in showing the acidity and the alkalinity. Can you see this litmus paper change from red to blue? That means there is hydroxide ion. How do you get the hydroxide ion? Oh, from our definition just now. Dissociation occur. Who dissociate? This alkali dissociate. Dissociate must be happen in where? Happen in the presence of water. When it dissociate, then it has the hydroxide ion. That's why the color change. And what is so special about the hydroxide ion to make it to be blue? Because this hydroxide ion is responsible to show alkalinity. Okay. Now, keywords of the question. Explain why only ammonia in water turns the red litmus paper blue, but the ammonia in propanol does not. Can you see they are giving you two conditions? Condition 1, condition 2. So when you explain, how many conditions should you write? 1 or 2? Response, please.
2.
Yes,
2.
you should do 2. Correct. They give you 2 conditions, you write 2 conditions. Now I tell you, we are going to move on to the answer. What does the student always do, including my own dear students? What do? Oh, they are very happy. They see, oh, you ammonia in water. So they put happily, they write ammonia dissociates in water to produce hydroxide ion 1 point. Then hydroxide ion is responsible in showing alkalinity. That's all their answer. But now they want you to explain about two conditions, right? So in exam, you might be getting 0 if you are talking about only one part, which is this. You don't talk anything about the ammonia. Then that's it. You are donating your marks. How many marks you have donated? You are donating 5 marks. So kind of you. Now continue. In this case, you can put your answers in a table form or in paragraph. Now, as what I show you on the screen here, actually, this is a guideline for you to answer your exam question. You can put in paragraph form means you write your title. Ammonia in propanol does not dissociate. There is no water, no hydroxide ion, full stop. So there is no hydroxide ion to show its alkalinity, full stop. Then another paragraph you put, but when ammonia in water, the dissociation occur, hydroxide ion present, and hydroxide ion is responsible for its alkalinity, full stop. You are comparing two conditions, so you will get the marks. If you don't compare, no marks, okay? If you are putting it in table form, very simple. Just put it in table lah. That's all. See, never chemistry be difficult. Who say chemistry is difficult? I cannot understand why. Eating is much more difficult. Okay, so this is your answer. So sometimes you will have this point. You must have this point, point 1, point 2, then you get 1 mark. This one correct, then only you get 1 mark. This one correct, then only you get 1 mark. But sometimes the mark scheme are very kind to you. Oh, they want to give you many marks. Oh, you write this one. You write this already. Okay, I give 1 mark. This one, another one. Okay, another 1 mark. Oh, this one you wrote now. Got no hydroxide ion present. Okay, 1 mark. Like this. So we don't know what they want. We do our part. Okay, so next part, we move on. Do you have any problem until here? No, No, Okay.
No.
Okay, good. Thank you. Very good. You all give me fast response. I love you all. Now we continue. Part B. Who have problem in the preparation of salt? Who have problem? Tell your name. No one has problem. Then this part I can skip. Yes or no?
No.
Oh, cannot skip. Okay. Now you are required to prepare dry zinc sulfate. First of all, when you talk about the preparation of salt, you are going to determine whether this salt is a soluble salt or insoluble salt. Okay. So now look at the sulfate, the N ion. N ion. When you see the sulfate, then you have to check, is it the lead 2 sulfate, the calcium sulfate, or the barium sulfate. If it is not these three, then others will be insoluble salt. If it is one of these three, then it will be the insoluble salt. These three are insoluble. Others, they are soluble. Given to you is these two substances to produce the salt. So now how do you do? From here, we are going to continue. This is the flow chart that you should use and learn how to describe the preparation of soluble salt. Don't care which soluble salt, as long as it is not group 1, not the ammonium salt. I am saying not. You are using this flow chart. If it is group 1 and an ammonium salt, in front here, you must add in the titration part. I repeat. If it is group 1 and ammonium, before this beaker, you add in the titration part. Now, no. So you don't have to do titration starting from here. Now this flow chart gives you marks. Number 1, what do? You talk about the acid, 1 mark. Number 2, you talk about the heating, 2 marks. Number 3, you talk about what you added in, 3 marks. And number 4, you talk about the stirring, 4 marks. Next, number 5, you talk about the filtration, you filter, 5. From this solution, you transfer into the evaporating dish, 6. Heat until saturated, 7. Cool and crystallize, 8. Filter to obtain the crystal, 9. And at last, you dry it by pressing it between pieces of filter papers, 10. Simple as A, B, C. This is the 10 steps for the preparation of soluble salt. And I'm very kind, you see, I give you answer. Remember, you see this pretty girl tell you, I don't put my face here lah. If I put my face here, you will no more mood to have the lesson. You look at this pretty girl. She reminded you, don't forget to write the volume and the concentration there, and I put purposely red for you. Now always remember the magic 5. The volume, put it to 50. Hey, what happened? The concentration put to 0.5 for sure, correct? Ignore my range. Just put 50 and 0.5. Name of acid, in our case just now I gave you what acid? The sulfuric acid. So you put the name, okay? Then you heat the acid. Now number 3, the question just now gave you the zinc carbonate. So you add in the zinc carbonate, okay? Remember to put until in excess. The rest of the part 4 to number 10 will be all the same for any type of the soluble salt. I am giving you sample answer for exam. Any problem before I move on? No, Okay, next. Remember what this pretty girl tell you? Volume and concentration. If you don't like, you put this statement there to tell you. Now we continue. Next part. Question 4. Okay, this is again the preparation of the standard solution, is it? Now, just now we were talking about dilution to prepare standard solution. Now this Ahmad, he has got nothing to do. He dissolved 38.4 grams of solid Y, put it into water, and this solid Y will enable him to get acid Y. And how much of acid he used? He wants only 100 cubic centimeter. So now he wants to calculate the concentration of the acid solution that he will get. Okay, so what will he get? How do you calculate the concentration? First of all, see here, you go for the number of mole. What am I doing? Okay, the number of mole. This is in gram, this is in gram per mole. So now you have gram and gram, up and down, you cancel off. Okay, you are getting the unit in mole. And we know that the concentration in mole per decimeter cube, you are getting the number of mole to divide by the volume. The volume must be in decimeter cube lah. And this one should be in, previously they said 100 cubic centimeter. If you don't know how to convert from centimeter cube to decimeter cube, you take this, divide by 1000. So you are getting, you divide by 1000, you are getting 0.1 decimeter cube. So you take the number of mole, divide by the volume, you are getting your final answer as this. Can you follow until here?
Yep.
I hope you can. Okay, thank you. Now. Oh, so sweet now, this voice. Who is this? What's your name, girl? Giving you slot online, I can't see your face. Can only talk to you. I'm like talking to myself. Now we continue. Next question. There I give you the bulk. How to prepare this 100 cubic centimeter, the 2 mole per decimeter cube of acid Y from its solid. Actually, this is on the preparation of standard solution. And from where? It is from the solid. Okay, so now I'm going to tell you the step briefly. Please know how to write the sentences on your own. Okay, now see. This one, you are actually going to show this calculation. You are actually going to show this calculation. Step 1, number of moles. Step 2, the step 2, in your textbook, they say they want you to determine the mass first. Let's say they don't tell you the 38.4 gram. They tell you they want only this solution from solid. So you have to determine the mass needed. So how you get the mass needed? You are taking the number of mole multiplied with the molar mass, and from there you get the mass. But for the question today, we have already know it is 38.4 gram. So first thing, you are going to weigh this 38.4 gram. You weigh it. I'm sorry, my drawing is not good. You please forgive my cartoon drawing. I am really not good about this. So you weigh it. This is the Y, the solid Y. After that, what you do is you are taking out this weighing bottle, put it here, transfer the solid into a beaker, and you add water. When you add water, of course, when you add things together, you remember to stir. Stirring will always give you marks in exam. You stir using the glass rod. So now what you do, you are going to transfer this into a volumetric flask. Keywords. When you are talking about the volumetric flask, please mention about the size. The size is from the volume. 100 cubic centimeter volumetric flask. You transfer inside there. This one, put in. When you put it in, it might reach only here. But you have to make it to reach the calibration mark up here. So what you do, you are going to add in the still water drop by drop. Remember, until it reaches the calibration mark, which is this one. Then you stopper and you shake it. Can follow the steps. If you can't follow, you please go and write down. Important. Can come out in your structure, can come out in your essay. Okay, now we continue. Next part. Any problem before I move on? No? Okay, now here inside the reagent bottle, it was shown that, don't know who is this, so smart. They add the zinc nitrate and the zinc chloride together. They have got nothing to do. Who is this? They add this together. Got no work. So now, you as a chemistry student, you have to determine the presence of the cation and anion in the solution. And in your description, you have to have all this, the materials, the observation, and the conclusion. So now, what is the cation that present? Can someone tell me? What is the cation that present?
The
zinc ion.
Zinc ion.
The anion?
The anion. Chloride.
Some more?
Chloride and nitrate ion.
And
good. Now these are the ions that present. So that means you are going to do the test for the zinc ion, which is the cation. Please don't tell this is zinc 2 ion. Don't be over smart. This is not the zinc 2 ion. This is wrong. Zinc is not a transition element, even though it is located at that block. But then it is not transition element. Do you know why?
because it has only one oxidation state.
Okay, correct. It has only one oxidation number, and it has no, it does not have the special characteristic of the transition elements. Remember the 4 special characteristic? The zinc does not follow this. So it is kicked out of the transition element. No more friend to them. Okay, now we continue. So for the test of the zinc ion, what is needed? For the test of the chloride ion, what is needed? And for the test of the nitrate ion, what is needed? You don't have to write one by one because you are going to get this when you are writing your test. Okay, see. Now, if you have problem to talk about the presence of the cation, then we are going to look at this. When you see cations, the substance that you can use to test will be either the sodium hydroxide solution or the ammonia solution. Ca means this one, I call it as the campus. Ca means the calcium ion, the M means the magnesium ion, the P means the lead 2 ion, this is the aluminium ion, and the Z is the zinc ion. Okay, now continue. What you do is, initially you are going to put few drops first, then you add until in excess. Okay, now if you put few drops of sodium hydroxide solution into the test tube which contain the solution that you want to test, if they are all these ions, if they present, they are giving you white precipitate. Even though I put it orange, it is actually white. I cannot put white, you don't see anything. So it will be the white precipitate here. Then you are going to put until a lot in excess. Then you see whether this white precipitate go away or not, dissolve or not. If they are having the lead 2 ion, the aluminium ion, or the zinc ion, this white precipitate will dissolve. That means you don't see it after that lah. And you have already actually remember this actually. I hope so lah. Now, if you are using the ammonia, we know that all this, the calcium ion, if it is there, you put the ammonia solution, there will be no change, nothing happen, no precipitate is formed. If you see there is white precipitate, then these are the ions that present. This one. And if you put a lot, this one, the white precipitate will dissolve. So in our case today, we want to test for the presence of zinc ion. So the best is to put the ammonia solution. First thing, you put a few drops first, then until in excess. Then you tell your observation. Okay, so now, next part. Later, in one of the slides, I will show you the way to write. Is it okay I show you later? Can I?
Teacher, can.
Okay.
Yes.
Now, for the N ion, thank you, so kind of you all. Now, for the N ion, what are the N ion that you are testing? Just now you said you want to test for the nitrate ion and also the chloride ion. So if you want to test for the nitrate ion, these three chemicals must be in sequence, cannot jump up and down. And when you are using these three substances in sequence, then you will get the marks. Next, when you tell brown ring is formed, you get the marks of the observation. And you say shows the presence of the nitrate ion. That is the conclusion. Okay, so you see how you can write your answer by including everything that you need in the answer. So for the test of the chloride ion, you are going to use any of the tests will start with an acid. Some books they started with the silver nitrate solution first. That one is wrong. The sequence must be starting from the acid first. You know why? Because you are going to eliminate any impurities by adding in the acid. Okay. What am I telling is we are testing for the cations and anions in a solution. That means it is a soluble salt. What if it is an insoluble salt? If I give you an insoluble salt and you were to test for the presence of cation and anion, your first thing is also to dissolve them in an acid first. After you dissolve them in an acid, then only you continue with your test. Can you get my point? If you can,
yes.
You tell me yes.
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 Thank you.
Understood.
Now we continue. So you put in the HNO3 followed by the AgNO3, and what is the name of the white precipitate? Inside the solution, it might have already the chloride ion. When you put in the silver ion, you are getting the silver chloride, and this is the white precipitate. Okay, now for this sulfate ion, not necessary you use the HNO3, you can actually also use the HCl. If you are using HCl, then you are using the barium chloride. Chloride and chloride, nitrate and nitrate cannot mix up. Sometimes in the objective question, they purposely mix up for you so that you get the wrong answer. Why they do so? Next part. Done with this question 4? No, Okay, now question 5.
Teacher.
Yes.
So if the acid is hydrochloric acid, we have to use barium chloride.
Yeah, I give you an example.
Okay.
If I have a solution, I tell you this is magnesium sulfate, and I want to test for the presence of the sulfate ion. So what do you do? Oh, hey, my lab has got no nitric acid. Never mind, I get hydrochloric acid. So you put 2 cubic centimeter of the the hydrochloric acid. Then you are going to add in, this is number 1. Number 2, you add in the barium chloride solution. Then you see, oh, white precipitate form. It shows the presence of the sulfate ion. And please remember, when you are using a test tube, you see, I put in purposely for you 2 cubic centimeter. 2 plus 2 equals to how many?
4.
Good. If you don't know, go back to your kindergarten. And this solution, maybe you put 5 cubic centimeter. 4 plus 5?
9.
Good. So altogether, you have only 9 cubic centimeter of solution in the test tube. Then you are correct. If you put this one, 5. Even though we say, when we want to test, we can put our volume from 2 to 5 cubic centimeter. Imagine you put this one 5, you put this one 5, you put this one 5. Altogether, it becomes 15. And it will be here at the part of the test tube going to spill. How to test? Cannot. Test tube or boiling tube, maximum 15 centimeter cube. 15. I repeat, test tube or boiling tube, maximum 15 centimeter cube. Always when you want to test for anything, use the volume to be 2 cubic centimeter. Like you, last time, olden days, Jurassic Park photo, you are taking photo like this, like what I always show. But then nowadays, you do like this. Again, it is still 2. You do like this, 2 fingers. You do like this, also 2 fingers, right? So remember 2. Okay? Next part. Any more questions before we move on? No, Okay, question 5. Oh, what is this? Who don't like this question? Anyone don't like? If you don't like this, you tell me. Anyone don't like this?
Don't like.
Oh, you don't like? Okay, I will make you love it. Because from this question, you really can get marks very easily. You know how to count 1, 2, 3 or not? You know, right? All of you very smart one. See, one product. 1 product, 2 product, 3 products, altogether 3, right? Then when you are heating a salt which give you 3 products, it will be for sure a nitrate ion at the salt. I repeat, if you get 3 products, you will sure get a nitrate. Okay? And if you see a PB here, then it will be still PB there. One day you ask Amin to run on the field 10 rounds. After Amin running on the field 10 rounds, it will be still Amin, right? Hey, where is my cursor?
It's right there, teacher.
It will be still Amin. Will it be Amin running on the field 10 rounds? After running, he becomes Amina?
No.
It cannot be, right? Cannot.
No.
Therefore, when you start with a PB, it will be always end up with a PB.
Yes.
Same goes to your carbon compounds. If you started with a 4 carbon atoms, at last it still be a 4 carbon atoms unless you change it to become an ester. If not, it is still 4 carbon atoms. Okay, come back to this story here. Whenever you are hitting the nitrate salt, if it is not group 1 nitrate, that means if it is not the sodium nitrate or the potassium nitrate, the products will be always 3 products. And whenever you hit anything, you are sure going to get an oxide to be formed. Okay. Now, what is important about this oxide? I want to give you 2 colors today. Okay. What are the 2 colors? First of all, the lead-2 oxide and the zinc oxide. Can you see the P and the Z? I arrange it in alphabetical order. So the P comes before the zinc. The P comes before the Z. And now I am going to give you the color when hot and cold. Now the lead-2 oxide, what is the color when hot? Anyone remember?
White.
I love you. It is not correct. It is brown. Okay. Brown when hot. Now after it becomes cold, the intensity reduces. The intensity will become lower, which is yellow. And this yellow you copy back here. This is also yellow. And now I want to give the color of the zinc oxide when cold. It is white. So you will see that the intensity of the color decreases. Can you see from a darker intensity to become a lower intensity, then it becomes white at last. This arrangement. And now, what is the color of the lead-2 oxide when hot? It is brown when hot, yellow when cold. And what is the color of the zinc oxide? The zinc oxide will be yellow when hot, white when cold. Remember this clause, this one and this one. This will be used in your exam for answers. Okay? And they like to always ask this question. Oh, something which is black. Don't care hot or cold, it is still black. That is the copper-2 oxide. The copper-2 oxide. Others oxide, normally it will be white. That's why our handsome just now, he guessed it as white. Okay? You are not wrong, but your guess this time is wrong. Not correct guessing. Okay. So you remember only these few colors and it will bring you far. Okay? Now we continue. We know that this lead-2 nitrate will be soluble in water. Therefore, when it is being put in water, what is the name of solution? Why? Can someone tell me? Lead-2 nitrate, put it to dissolve in water. What solution you get? You put chocolate, dissolve in water. What drink you get?
Chocolate drink.
Chocolate drink lah. There. You put lead-2 nitrate in water, you are still getting lead-2 nitrate solution. You cannot put chocolate into water, then you get orange juice. So, this one the same. Lead-2 nitrate dissolved in water, you are going to get lead-2 nitrate solution. With the sodium carbonate solution. Why with the carbonate and yet it is a solution? All the carbonate salt are insoluble, right? But then don't forget, if it is a group 1 carbonate or it is an ammonium carbonate, it will dissolve. That is the reason. Okay. And you see the word precipitate. Precipitate means it is an insoluble salt. Indirectly, they are telling you this part here that I put the arrow in green. This part, the whole part here that I am going to circle now, this is actually the double decomposition reaction to produce insoluble salt, which is called as the precipitate Z. So now what is the precipitate Z? Very simple. We cut half, positive ion, negative ion, positive ion, negative ion. The positive from the front will always good friend with the negative from the back. So you are getting PbCO3. And these two, it comes together. You get the sodium nitrate. Balance up the equation. But what I want you to take note is that this name, it is called as the lead-2 carbonate. Because it started from lead-2, it will be always ending with a lead-2. It cannot become lead-4. unless you are putting any solution in it and it causes it to undergo oxidation. Okay? Can you understand it better now?
Understood.
Yes.
Good. I hope you
Yes.
like this type of questions. Because of what? If they ask you to name something from all here, the marks will be all from the diagram. That's why I always say the chemistry is a question that is what we call it as this karangan bergambar. I always tell it is diagrammatic chemistry. Okay? So from here, if you add the lead 2 oxide into the nitric acid, of course, neutralization occur. You'll still get this lead 2 nitrate and water. Okay? So I'm going to move on. See what does the question want. They ask us to write the chemical equation for the reaction between Y, which is the lead 2 nitrate with the sodium carbonate. I have written for you, and state the name. So this is the name. Now please take note about this word, double decomposition. It is a reaction. If they want to ask you about the method, then it will be called as the precipitation method. Same goes to like neutralization is a reaction. Titration is the method. Okay? But some books, they put an equal in between them. And at which I couldn't accept it because it is not accurate. Now we continue to the next part. Now, this is the part I want to show you the way of writing the test for the N ion. We know that the N ion is the nitrate ion. And we want to describe a chemical test to verify the N ion. As what I promised, I'm going to show you the way to write. First of all, of course, you are going to tell pour 2 cubic centimeter of solution Y into a test tube. Whenever you want to test, what you want to test, you put into the test tube first. 1. Next, you add 2 cubic centimeter to a dilute sulfuric acid, which contains solution Y. Next, followed by, can you see? I am telling you very clearly that I put in this solution first, then I put in the iron 2 sulfate solution. Again, 2 cubic centimeter. Next, I say I put a few drops of concentrated sulfuric acid. Remember, if you are using anything concentrated, please add in the word slowly and carefully. If you don't have this part, you don't get points for this.
Does
Okay?
it count as a precaution, teacher?
This is a precaution, but when you are writing a chemical test, this sentence, if you are using the concentrated solution, you have to use the word slowly and carefully. Okay? If you write without this part, you just put then add a few drops of concentrated sulfuric acid, full stop. No marks. Okay? Because when we are dealing with chemistry, whenever we have concentrated solution, we have to be careful. As what your teacher always tell you. Do it carefully. You are using concentrated sulfuric acid today. Your teacher love you so much, they will sure remind you. Okay? Now, next part. You are telling the brown ring is formed. This is the observation, and it shows the presence of nitrate ion. So now, calculate for me. Total in the test tube. What is the volume? What is the total volume? 2 plus 2 plus 2, 6, plus these few drops. Let's say if you are adding in 3 drops, so 6 plus 3, you are getting 9 only. 1 drop is approximately 1 centimeter cube. Okay? So let's say you move on for your higher level when you study chemistry. If your lecturer say, okay, put 1 centimeter cube, you no need go and take a measuring cylinder, measure 1 cubic centimeter, then only you put. Approximately means you put 1 drop lah, that is 1 cubic centimeter. Okay? Can now, next part. Can I move on Are you okay?
Yes. Okay.
Wait, so
Thank
teacher,
you.
wait, sorry, teacher.
I couldn't give you rest time because I am rushing to complete all. I want to give you as much as possible. Okay? Now, part D, keywords, compare and contrast. What does compare and contrast mean? Compare and contrast means you have to write the similarity and differences. Again, observation. That means what you see only. You don't write the name of the product. When the solid PbNO3 and the precipitate Z are heated. Precipitate Z, as what we mentioned, it is the lead-2 carbonate. We get it from our chemical equation just now. So when it is heated, what do we see? Can you see? Color of the residue when hot and cold. So when you heat this, what is the residue? And what do you observe in terms of the gas? So let's next move on. This is something that you should know. This is a chemical equation that represents the heating of the lead-2 nitrate. Now, not necessary you put the state of matter behind. For example, you put the bracket in G for gas. Not necessary. If you want to put, it must be all correct. And some books, they will write for you, when it is heating, you put a triangle up here, above the arrow. No need for SPM. Now, when this is heating, we want to compare. The question says, you are going to compare and contrast the observation when this substance is heated. I want you to take note about the word residue. Which is the residue? Residue is something which is left out in the test tube after the heating. So what is left out? Of course, the lead-2 oxide left out. And what are the gases? The gases will be the nitrogen dioxide gas. Yes, oxygen gas, and one more.
The
Carbon dioxide.
Yes, the carbon dioxide gas. So we are going to compare and contrast in terms of this. Why they ask us to compare and contrast? I previously mentioned compare and contrast means you must have similarities. You see, now I put a handsome boy. Just now I put pretty girl. Now I put handsome boy for you. If I keep on putting pretty girl, the girls would have show pretty girl only. We want to look at handsome boy only. I don't know which Korean star you like, so I don't put. If I know, I put for you. Now is what time for Korean star, is it? I cannot sing the song for you. If I can sing, I sing for you. Now here, similarity and differences. Put it in table form. Why table form? Again, we want to get it accurately so that we can compare left and right to give you the points. Now this arrow, I change place. Why suddenly they move out from the place that I put them? They don't know how to listen to instruction also. This one change here, okay? Now, when we are talking about the product of heating, color when hot and cold, so we are actually talking about the PbO. Did you remember? I told you to remember the color just now. Brown when hot, yellow when cold. Write this. Yes. So you write this one and this one. Even though you copy back the same, actually it represents the similarities. So you get 1 point. Now, the gas produced, they want us to talk about the color. We know that during the heating of the lead-2 nitrate, we get the nitrogen dioxide gas and the oxygen gas. So the brown belongs to the nitrogen dioxide gas and the colorless belongs to the oxygen gas. And same goes to this. The heating of lead-2 carbonate give you carbon dioxide gas. Okay? Can follow until here?
Yes.
Yes, Okay, next. Wow, you see so many marks given to you in the question. 8 marks. You have written only this one 1 point, 1 point. If I give you this one together 1 mark, this one 1 mark, 1 mark, and 1 mark, you have not reached the marks. You count, you cannot reach 8 marks yet, right? You get only 4 marks here. How do you reach the 8?
Verify it again.
Smart a bit we work smart. The brown gas, what does it do? It turns the blue litmus paper red. And please make sure you have the word. My answer don't get, this line don't give you marks. Brown gas turns blue litmus paper red. No marks. Why no marks?
Because we didn't tell what that brown gas is.
No. You have to have the word moist. If there is no water, can show acidity or not? Can show alkalinity or not? No, right? In this case, they just want us to talk about the observation. The name is not important. Of course, if you accidentally put the name there, but you also put the observation, okay lah, you get marks for the observation only. The name don't get marks. If the mark scheme wants to give marks for the name, then you put in, you get the name. It's not wrong for you to put in the name, but then not necessary you will get the marks. Okay? So if you want to put in, it's okay. Then we talk something about the oxygen gas. It rekindles the glowing wooden splinter. Again, actually, this is actually the test of gases. And for the next one, this colorless gas, we know that it is carbon dioxide gas, so it turns the lime water chalky. If you don't want to use the word chalky, you use the word cloudy. No using milky. No using milky, cannot. Okay? Any problem before I move on? No,
No.
Okay, next part. Question 6. Oh, again, the question that you don't like. Go on, Okay, now, do something to the diagram. I call you later, I'm having swap. Now we continue. You have substance Q, you have solid U, and gas R. How many products here? You can calculate, right? You can count, How many products? Someone? No one is here. 6 products. 6. I love you. How you get 6? When this one heated, this one product, this one 2 products. 2 only. Now, when you get 2 products, it will be having the carbonate ion. I repeat, in our question 5, 3 products, nitrate ion. Question 6, 2 products, carbonate ion. And they gave us hints. Solid U is in black color. And just now I told you, whenever you heat anything, you are going to get an oxide, right? What oxide is black in color? Just now I told you.
Copper
oxide.
Copper oxide, I give you 1 fish, cannot.
Copper 2 oxide.
You
Copper
grill
2
later.
oxide.
Copper 2 oxide only correct. Why must mention the 2? Because the copper is a transition element. Okay, now we continue. So we know this is the copper 2 oxide and 2 products. And therefore, this is actually the copper 2 carbonate. Can follow?
Yes.
There, amine, still amine. Cannot become amina. Okay, now next part. Oh, now I put this copper 2 oxide put into dilute nitric acid. If you are not sure, you write the equation. You are getting copper 2 nitrate and water. Put a 2, put a 2. So, is this equation balanced? And what is the solution Z from the equation that I showed? It will be the copper 2 nitrate. This one is the copper 2 nitrate. Okay, now move on here. Substance Q. Substance Q. Copper 2 carbonate you put into sulfuric acid. So what do you get? If you don't know, you write the chemical equation. So you will be getting CuSO4, carbon dioxide. One more substance. What is left out here?
Water.
Yes, good. Water. Okay, next. Oh, you have solution V. So what is the solution V? The copper 2 sulfate is the solution V. The gas R is the carbon dioxide. I hope you agree. Do you agree?
Yes.
Yes, okay, now.
Yeah.
I put this solution. Solution CuSO4. I put a metal inside there. Metal and solution. In your redox reaction part, you study that this is displacement. So you want to displace this solid X. Can you see? You want the solid X to come out from the solution. Then what should it be? What should be the metal? The metal should be something which is more electropositive than the copper. In this case, we are not using any fire. We don't use the word reactive. We use the word electropositive. Okay? How do you determine the electropositivity? You can refer to your reactivity series that you have studied in your Form 3 science, or you can refer to the E0 value. Okay? Now we move on. Next part of the question. Oh, we are asked to draw a diagram. Can you see label? Now, when we are talking about the label diagram, the diagram must be workable. What is the meaning of workable? I'll tell you. Okay? And we are going to convert the Q to solid U and R. Which part is that? The Q to solid U and R. That means it is the heating of the copper 2 carbonate. And in our diagram, got special request. We want to show how the gas is tested. How? Simple. This one. Okay? So this Q, if you don't want to label it as Q, you can label this as copper 2 carbonate. And I want to tell you which part that will be that we will look at for this workable diagram. Number 1, make sure this stopper does not cut the delivery tube. Number 2, make sure this stopper is a little bit out from the delivery tube, from the test tube or the boiling tube. I'm showing you something which is wrong. Your friends like to draw like this, included my students. After drawing this, they tell me, teacher, I'm done. Yes, you are done. Your chemistry paper also done, finished. You don't get A. Why? Because this stopper, it goes into the into the boiling tube. When you want to wash this boiling tube, how you want to wash? How you want to take out this stopper? You are going to break this boiling tube to get this stopper. Cannot be, right? So this one must come out. Remember, and it cannot cut cross. Next, it is the clamp of the retort stand. And this copper 2 carbonate is a solid, so you put diagonal lines. Next, for the lime water here, remember to put the clamp. Make sure this delivery tube enter the lime water. Delivery tube immerse into the lime water. This part, the part that I put in green, this one, no need to touch the substance. But this one must enter to the lime water. And this is a solution, so you put dash line. I repeat, solution, dash line. Solid, diagonal lines. Okay? Now, don't forget to put the word heat. No need to draw Bunsen burner. I know you are good in drawing, but exam no time for you. Just put an arrow, put heat. One arrow is enough. So this is the part for the converting of U and from the converting of Q to U and R, and this is the part to show the presence of gas R. Any problem? No. Now let's say you don't draw this set up in an L shape. You can draw U shape. U shape means your test tube is like this. This is the lime water. This is the substance Q. The delivery tube stopper, all you follow. Okay? Or you can draw it in a V shape. V shape means the same thing. This is the carbonate compound. This is the lime water. The stopper and delivery tube, all correct. All the same. Okay? So you have 3 methods to draw this part. Number 1, the U shape. Number 2, the L shape. And number 3, the V shape. This is wrong. This stopper goes in one is wrong. Any problem before I move on? No. Now next part. Oh, Z and V are the products, and name the possible metal cation. Metal cation in solution Z. Which is the solution Z? What are they talking about? The last part you see. So the possible metal cation will be the copper 2 ion. remember to put the 2 there. And we are now going to describe the confirmatory test for the cation mentioned in B1. You see, all the answers that I am giving you now is all from the analysis of the diagram. Okay, analysis of the diagram. Now we continue about the confirmatory test of the copper 2 ion. We know that this copper 2 ion is a cation. So for cation, we can either use the sodium hydroxide solution or the ammonia solution, the easiest. And now next, again, you put this solution Z, 2 cubic centimeter, into a test tube. If I choose to put sodium hydroxide solution, I put sodium hydroxide. If you don't like, then you can replace with the ammonia solution. Again, have to mention the volume, 2 cubic centimeter, or you can put it as a few drops. But then at last, you have to tell until in excess. Can you see I purposely put the red for you? Okay, have to mention a few drops, then until in excess. This is the part that I want to tell you just now. I say I'm going to show you the answer later. This is how you write your answer. And if you are having copper 2 ion, you will sure get blue precipitate. First of all, you tell when it is in the few drops of sodium hydroxide, you get blue precipitate.
Blue precipitate.
And you put a lot inside, it is insoluble in excess. Have to tell what is the condition when it is in excess of the sodium hydroxide solution. But if you are using the ammonia solution, then this blue precipitate will dissolve to form a dark blue solution. Out of this, the copper 2 ion, the iron 2 ion, and the iron 3 ion, all this you can be tested. They can be tested using the sodium hydroxide or the ammonia. For the sodium hydroxide solution, this precipitate, they are all insoluble in excess. Of course, this one will give you the blue precipitate, this one will give the green, this one will give the brown. And in ammonia, these two will give you insoluble precipitate, but only the copper 2 ion give you soluble precipitate in excess ammonia, giving you dark blue solution. Okay, so this is the part that I want to tell you. And now, next part. Remember, when you are writing a chemical test, what you must have, I purposely put on the page for you. You have to remember, have to put the method. Method means you are starting your answer by writing the verb pour, add. Don't put test using. If you put test using sodium hydroxide solution, you get one fish. Cannot, it's wrong. Okay, the reagent there, you tell sodium hydroxide solution, this is the reagent. Observation is the color of the precipitate that you form. And what is the conclusion? I have not written for you. The conclusion in this case, it will be the copper 2 ion presence. That's all. Any problem with the writing of chemical tests? No problem. Now we move on to the next part of the question. Now here, we want to describe how to obtain crystal of salt V from the solution. What is the salt V? Refer back to the question just now. The salt V is actually the copper 2 sulfate. How do you get it from the solution V? So we are actually using the diagram that we have already used just now to describe the procedure. So how to get the V? Actually, the solution is all done. This is the copper 2 sulfate solution. So we are going to start to mention from here. Number 1, you are going to heat the copper 2 sulfate solution or the salt V, keywords are until saturated. Next, you cool and allow it to crystallize. Number 3, filter to obtain the crystals. Number 4, dry the pieces of crystals in between pieces of filter papers. Now, do you see I rinse anything here in this part? No rinsing when you are talking about soluble salt. If you rinse, all your solution, all your salt will dissolve. Okay, so you don't rinse. Any problem for this part? No, okay, next. Metal M is more electropositive, so you are going to name. Can you see the word name? Name means you have to spell it out. Like when I ask you to write your name, you won't draw your face, right? So you spell it out. And what is the metal that you can use? You can actually use the must. Magnesium, aluminium, or zinc. Don't be so smart. Use the potassium, sodium, and the calcium. Use the must. Okay. Next, go back. What is needed? We write the observation for the reaction. So this is the salt. This is the metal that we can add in, and we have to name it lah. If you want to add magnesium, so you write out magnesium is added. So what is the observation from this chemical equation? You can have two observations. Observation number one, you talk about this copper 2 sulfate solution. We know that it is blue, and this magnesium sulfate is colorless. Okay, so this is observation number one. Observation number two, you can talk about this. The brown solid is formed. Any problem? So the hint is, whenever you can write a chemical equation, you please write and your answer will be there. Any problem?
No problem.
Okay, now move on to the next part, the last part of the set, which is part E. You are given with three types of chemicals, the zinc oxide, the sodium carbonate, and the dilute nitric acid, these three types. And from these three chemicals, you are going to prepare a dry zinc carbonate. First of all, is zinc carbonate a soluble salt or insoluble salt? What do you think?
It is a insoluble salt.
Insoluble salt.
Good. Carbonate compound, they are all insoluble except the group 1 carbonate or the ammonium carbonate. So when we know that it is an insoluble salt, meaning we must have two solutions. Solution A and solution B. We add together. But do we have a zinc solution here? We don't have,
No.
right?
We do not have a zinc solution.
This is a solid. This is not a solution. So we have to produce a solution from here. And we have already get the carbonate solution, which is this. So you keep this alone. Don't bother this. Keep it. Don't disturb. And from the zinc oxide and the dilute nitric acid, you make the zinc solution. Therefore, your steps will be this. First thing, you are going to react with, they give you the nitric acid, I'm sorry. This is the HNO3. You are getting the ZnNO3 and the H2SO4. Okay, with this, you get the zinc nitrate solution. Now you get the zinc solution already. Next step. So you are putting the zinc nitrate solution into the sodium carbonate. And now you are going to get the zinc carbonate and the sodium nitrate. Okay, you follow my blue equation. Yes. Equation 1 is to produce the zinc nitrate solution. Equation 2 is to put the zinc nitrate solution that you have produced with the sodium carbonate solution given to you to give you the salt. So in this case, in your description, you must describe two processes. One is the preparation of zinc nitrate solution using this method. Again, this picture. My picture, please come out. Using this picture, but you reach until here enough. I hope you understand.
Just the filtration.
Yes, just the filtration. Why? Because when you have done until here, what you want is only this, the zinc nitrate solution. You want the solution. You don't want the crystal. So you don't continue with this part. This part don't. Okay. Now you get this solution already. You are going to continue with the double decomposition reaction that I am going to show you now. Okay, this is the one. A pretty girl come again. Now you need the two solution. What is this solution A? This is what you have prepared just now. The zinc nitrate the zinc nitrate solution A. Okay, and the solution B, it is the sodium carbonate solution. You add this one solution to another one. So how do you get your steps from the picture? Step 1, measure and pour the zinc nitrate solution into a beaker. Step 2, into another beaker. Step 3, you add them together. Don't forget, when you add things together, step 4, you stir. In this case, step 4 is stirring. In the first case of the preparation of soluble salt, step 4 is also stirring. If you don't get that part, later you get the record from your teacher and you watch again. You will find that step 4 is always the stirring. Okay? Now you want this precipitate only. So you filter. Now in this case, this precipitate is the zinc carbonate. Okay. This one, the residue is the zinc carbonate. You want this. This one, you don't want. The filtrate don't want. So now,
teacher,
how you, yes?
you have to continue stirring when it's filtrating, right?
No. When you filter it, you don't stir. You know why? Because if you stir, this filter paper will get wet and it will be torn very easily. So if you stir while you are filtering, then the filter paper torn and all this precipitate will be mixed with the filtrate again. But why you still see the glass rod here? This glass rod here is not for stirring. This glass rod here is, let's say I am, how to draw the picture? Let's say this is the solution that I pour. I want to filter this solution here, this green solution. I want to pour it down into the filter funnel. So I am using this glass rod to direct this solution into the filter funnel. To direct it there. Okay? So now, here in this case, after you have filtered, you have to rinse the precipitate with some distilled water so that the solution which is stick on the zinc carbonate that you don't want, which is the sodium nitrate, will be rinsed off to the filtrate. And what is left up here will be the zinc carbonate that you want. Then you press in between pieces of filter paper to dry it. Then happily you are getting all your points with the dry zinc carbonate produced. This diagram shows the preparation of insoluble salt. And this pretty girl reminds you to describe the preparation of insoluble salt using the diagram shown to you. Any problem? Any questions you would like to ask me? From number 1 until number 6? No, Okay. So with this, I think all my slides are done. And I hope you can get what I'm trying to tell you. I'm really sorry there is one part that I cannot put in, that is on the continuous variation method, on how to construct the ionic equation using experiment method. Really not enough of time because for that question, if I want to put in, then it will come to 2.5 hour session. Okay, so I try to put everything in from this chapter into the questions that I have given to you. I hope you benefit. And with this, this is the procedure that I want to show you. The volume and concentration, remember to put okay. And with this, I say a thank you to you. And if I'm using any words that I hurt you or I make you to be unhappy this morning, I would like to apologize. And all the good parts